Now, knowing that there's a spatial correlation, there are some tools that can be used to manage that correlation and to take advantage of it, and also to take care and be careful if something is not useful for what we want to do. The first example here would be the use of geostatistics. This is a very broad science where the main objectives of geostatistics would be to, by using the spatial correlation information, you can do differentiation. So if I have points in an area and I would like to know what would be the most probable value of this variable throughout the whole area in a raster, for example, like in this case, covering the whole area, geostatistics allow me to do this, understand that correlation and how similar are the points and how I can establish a value in a point that has not been shown. So this is a linear combination of the different values where the sampling took place. So this is very common in precision agriculture, for example, in several different sciences and scientific studies that require knowing what's the behavior of a variable throughout the whole area, but there's no way on how to do this in the whole area. So you have to take samples, and this sampling process, it requires us a certain amount of points that have to be done. Otherwise, also the economical factor is very important. So this is one of the applications of spatial correlation in geostatistics. So that is to foresee the value of the variable where it's not known. And one of the differences is that, generally speaking, this data has the exact coordinates. It's very common to have a point data. So you don't begin by defining who are the neighbors. What we do is to calculate the correlation or the variability between the different points that are available. So if I have a point over here, I can compute the variability with this point. That means the difference. And with this one and with this other and all the other points. And this is going to generate a variogram cloud, which is the variability between each point. And I can represent this as a function of distance. So that distance, in the case of 2 dimensions, in the spatial case, would be the distance between 2 points. But it can also be done for time, or that can be represented in days or years. So it's a measure of time in space, and each point represents the variability or the difference between 2 points. You cannot do too much with this because there are too many points, and it's very hard to use this information. So what can be done is that you can add other information by distance intervals, and this is how you get a variogram. So every point in this variogram represents the average of the different points that were between these distances, and this line would be the theoretical variogram or the model, and this model is what can be used afterwards for for having spatial estimations. So with this, you have the possibility to attribute optimal weights to each one of the close neighbors in order to have an estimate of the value where you don't know the value. This tool is very important in order to understand the spatial correlation. And there are different names for the part of this graph. This initial part is called the dot effect, and it represents the variability that cannot be explained spatially speaking. So if I take 2 points in the same location, the expectation would be to have the same value. Since there's no distance, the distance will be 0. But there are still errors on the sampling, on the analysis, etc. So this dot effect represents this variability in a very close scale to 0 meters because of different factors. And all this part that you get over here up to this up to the top would be the spatial dependency, the part of the variability that can be explained based on the neighbors. If I have closer neighbors, generally speaking, I could explain a higher number. Or if I have further neighbors, the capacity to explain the correlation starts to decrease until a point that's called the range, where this value increases and it's a function of the distance. So after that point, we have spatial independency or independence. So if I'm this part of the distance, then at this point I would need to use geostatistics or a spatial analysis that have to be taken into account by the correlation. If I'm working with data in a distance uh, that's out of range, then the data would be independent, and the other methods can be used for this. So it's important to understand the usefulness of this tool.